So we will start straight line in 3 dimension. So that is straight line in 3D. So in 3 dimension, straight line can be formed by intersection of 2 planes. So intersection of 2 planes is called its unsymmetric form. That is, if we will say that is 2 planes intersect each other, then their common point is a straight line that is called that is unsymmetric form. So it is represented by pi 1 is equal to 0 is equal to pi 2, where pi 1 and pi 2 are 2 planes. That is, suppose the plane is a1x plus b1y plus c1z plus d1 is equal to 0 is equal to a2x plus b2y plus c2z plus d2. So this is called unsymmetric form, and other form is called symmetric form. So in symmetric form, a straight line equation can be defined as if a point, say A, given point having coordinate x1, y1, z1, and so it is a given point A having coordinate x1, y1, z1, and direction ratios of line is a, b, c. So if a point is given and direction ratios of a line, so equation of straight line can be obtained by taking any arbitrary point x, y, z, that is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So this is called its symmetric form of equation of line. So we can change from unsymmetric form to symmetric form of equation of line. Suppose we are given unsymmetric form of equation of line. So one example is, say, x minus 2y plus z plus 5 is equal to 0 is equal to 2x plus y minus 3z minus 1. So convert into symmetric form. So this is written in unsymmetric form, we can express into symmetric form. So these two equations have 3 variables. So we can put any one of the variable as 0 or any number. If we put z is equal to 0 in both the equations, then it will be x minus 2y plus 5 is equal to 0, equation 1, and 2x plus y minus 1 is equal to 0, equation 2. So now the equation has 2 equations and 2 unknowns. We can solve by equation 1 plus 2 times equation 2, that is x minus 2y plus 5 is equal to 0, 4x plus 2y minus 2 is equal to 0. Now if we add these 2 equations, that is 5x plus 3 is equal to 0, that is x is equal to minus 3 by 5. And similarly, equation 2 into equation 1 minus equation 2, that will be 2x minus 4y plus 10 is equal to 0, 2x plus y minus 1 is equal to 0. Now by subtracting these equations, we have minus 5y plus 11 is equal to 0. So y is equal to 11 by 5. So the point is minus 3 by 5, 11 by 5, 0. Next, to find the direction ratios. Suppose ABC is be the direction ratios of line. The line whose direction ratios and but any other point, fixed point we have minus 3 by 5, 11 by 5, 0. As both the normals to the plane are perpendicular, so we have direction ratios of normals to the plane are 1 minus 2 1 and 2 1 minus 3. As normals are perpendicular to line, so this implies a minus 2b plus c is equal to 0, 2a plus b minus 3 is equal to 0. Now we can solve these two equations by cross product. So that will be a by minus b plus c. So it is a by minus 2 into minus 3 minus 1 into 1. Similarly, minus b by 1 into 3 minus 2 into 1 and c by 1 into 1 minus 2 into minus 2. So that is a by 5 minus b by minus 1 is equal to c by 5. So direction ratios of line are 5 1 5. So we have the direction ratios and a point. So equation of the line in symmetric form is x minus 3 by 5 divided by 5 is equal to y minus 11 by 5 divided by 1 is equal to z minus 0 by 5. So this is in symmetric form of equation of line. Next we have, so this is Cartesian form of equation of line. Next we have vector form of equation of line. So vector form of equation of line, suppose B is any vector and a line parallel to it having a point P whose coordinate is, whose position vector is r, and A be any other point whose position vector is A. So the line L is parallel to vector B. So AP is obviously parallel to B vector and AP vector is equal to position vector of P minus position vector of A, that is R minus A is parallel to B vector, that is R minus A vector is some constant T times B vector, where T is a scalar. So R vector is equal to A plus T times B vector. So this is called vector form of equation of line. So next we have the Cartesian form. So Cartesian form is nothing but XY form. If we have given two fixed points x1, y1, z1 and x2 y2 z2. Then equation of line through 2 points A x1 y1 z1 and B x2 y2 z2 is x minus x1 by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1. So, this is equation of line in 2 points. Suppose we are given any 2 points, we can find the equation of line. Say equation of line through minus 1 3 2 and 5 4 minus 1. So, these 2 points are given. So, we can put directly the formula, that is x minus minus 1 divided by 5 minus minus 1 is equal to y minus 3 divided by 4 minus 3 is equal to z minus 2 divided by minus 1 minus 2, that is x plus 1 by 6 y minus 3 by 1 z minus 2 by minus 3. So, this is equation of line in Cartesian form. So, in vector form also, in vector form we also find the equation of line. Suppose 2 points A and B are given having position vector A vector and B vector. If we consider the position vector, then origin as the reference point, that is A vector, OB as B vector. Suppose R is any point on the line having position vector R vector, P is any point, then AP is parallel to AB vector. Now, AP vector is equal to position vector of P minus position vector of A, that is R minus A vector, is equal to T times AB vector. AB vector is position vector of B minus position vector of A, that is B minus A vector, where T is a scalar. So, R is equal to A plus T into B minus A vector. So, this is equation of line in 2 points, that is in vector form, or we can simplify it, that is equal to. So, next we have angle between 2 lines. First we consider in Cartesian form. Suppose the 2 lines are L1 and L2 and angle between them is theta, that is x minus x1 by A1 is equal to y minus y1 by B1 is equal to z minus z1 by C1. This is line L1, and x minus x2 by A2 is equal to y minus y2 by B2 is equal to z minus z2 by C2, line L2, and say angle theta is between L1 and L2. So, we have cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 divided by plus minus root over of A1 square B1 square, C1 square, A2 square, B2 square plus C2 square. So, this is angle between two lines, and if theta is equal to 90 degree, two lines perpendicular, and the condition is A1 A2 plus B1 B2 plus C1 C2 is equal to 0. If two lines are perpendicular to each other, angle between them is 90 degree. Similarly, if theta is equal to 0 degree, two lines parallel, that is two lines are parallel. So, condition is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So, this is condition of perpendicularity and parallel. So, this is in Cartesian form. Now, we can have vector form also, that is in vector form the two lines are represented by r vector is equal to A1 plus t times B1, and r vector is equal to A2 plus t times B2. So, this is two lines in vector form, and angle between them is cos theta is equal to B1 dot B2 divided by magnitude of B1 into magnitude of B2. So, this is angle between two vectors in vector form, and if theta is equal to 90 degree, then obviously B1 dot B2 is equal to 0, and if theta is equal to 0 degree, B1 cross B2 magnitude B1 cross B2 is equal to 0. So, two vectors are perpendicular or parallel. So, this is called angle between two lines. So, take one example, that is two lines are, say, x minus 2x minus 1 by 3 is equal to x y plus 3 by minus 2 is equal to z minus 1 by 4, and x plus 1 by 2, 2y minus 1 by 3, 3z plus 1 by 5. So, angle between two lines. So, this is obviously in Cartesian form. We can first of all write down its in general form, that is x minus x1 by a 1, y minus y1 by b1, z minus z1 by c1, and x minus x2 by a2, y minus y2 by b2 is equal to z minus z2 by c2. This is in this form. We can take common 2. The first line will be 2 into x minus half by 3 is equal to y plus 3 by minus 2 is equal to z minus 1 by 4. So, taking 2 common shows that coefficient of x is 1. Now, divide 2 in both numerator and denominator. So, 2 cancels out. Similarly, this is line 1, and line 2 will be x plus 1 by 2 is equal to 2 into y minus half divided by 3 is equal to 3 into z plus 1 by 3 divided by 5. So, in first part we divide 2 and 3 such that their coefficient is 1. So, this is line L2, and the direction cosines ratios of L1 are 3 by 2 minus 2 4, and direction ratios of L2 are 2 3 by 2 5 by 3. So, this is A1 B1 C1 and A2 B2 C2. then cos theta is equal to 3 by 2 into 2 plus minus 2 into 3 by 2 plus 4 into 5 by 3 divided by plus minus root over of 3 by 2 square plus minus 2 square plus 4 square root over of 2 square plus 3 by 2 square plus 5 by 3 square. So, this is on simplifications gives cos theta is equal to 20 by 3 divided by plus minus root over of 9 by 4 plus 4 plus 16, that is 20 plus 9 by 4, that is equal to 89 by 4 into root over of 4 plus 9 by 4 plus 25 by 9. So, this is on simplification. We have the angle theta, that is equal to 20 by 3 by plus minus root over of 89 by 4 into root over of 144 plus 81 plus 100 divided by 36. So, this is on simplification. We have theta is equal to cos inverse the angle. So, that is angle between two lines. So, next we will find angle between a line and a plane. Line, that is x minus x1 by a, y minus y1 by b is equal to z minus z1 by c, and a plane, that is ax plus by plus cz plus d is equal to 0. So, suppose angle theta between a line and a plane. So, we can represent a plane in form of a rectangle or a parallelogram. This is line L and a plane pi. Say angle theta is in between them. So, angle between a line and a plane is also can be also found out by drawing normal to plane, and angle between normal and plane is pi by 2 minus theta. So, if theta is angle between line and plane, then angle pi by 2 minus theta between normal to plane and line. So, why normal? Because A, B, C are direction ratios of normal to plane. So, direction ratios of normal to plane is A, B, C, and direction ratios of line is small a, b, c. So, this is direction ratios of line, and if 90 minus theta is angle between plane and line, then cos 90 minus theta is equal to a into a, b into b, c into c divided by root over of a square, b square, c square, root over of a square plus b square plus c square, or rather we can say cos 90 minus theta is sin theta is equal to a into a plus b into b plus c into c by plus minus root over of a square, b square, c square, root over of a square, b square plus c square. So, this is angle between a line and a plane. We can have in vector form also. So this is in Cartesian form. In vector form, the line is represented by r is equal to a vector plus t times b vector, where t is a scalar or a constant, and a plane is denoted by r dot n vector is equal to d, where n vector is normal to plane. So angle theta between line and plane, if angle theta is between line and plane, then angle pi by 2 minus theta between line and normal to plane. So we have cos 90 minus theta is equal to b vector dot n vector divided by magnitude of b vector, magnitude of n vector. So this is angle between line and normal to plane, or rather we can represent it as a sin theta is equal to b vector dot n vector divided by magnitude of b vector, magnitude of n vector. So this is in vector form and previous in Cartesian form. Next we will discuss the condition of coplanarity. So what is called coplanar? So this blackboard is itself a plane. Suppose I say that a line x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c lie on a plane ax plus by plus cz plus d is equal to 0. Suppose I will say that a line lies on a plane. So the conditions is, first of all, the point of the line, point x1 y1 z1 on the line. So there must be the common point x1 y1 z1 lie on the plane also. So it satisfies the equation of plane. So the condition is ax1 plus by1 plus cz1 plus d is equal to 0. So this is the first condition. So it is the only conditions. It may so happen that line intersect the plane and that is a common point. The second condition should be the normal which is perpendicular to plane is also perpendicular to line. Suppose this is normal n. So normal n perpendicular to plane is also perpendicular to line. So this implies the product of direction ratios is equal to 0. So a plus b into b plus c into c is equal to 0. So this is conditions 2. So these two conditions are necessary for a line to be on the plane. Next we will, that is two lines are coplanar. Next we have two lines, say x minus x1 by a1, y minus y1 by b1, z minus z1 by c1, and x minus x2 by a2, y minus y2 by b2, z minus z2 by c2. Suppose this is line L1 and line L2, and a plane is ax plus by plus cz plus d is equal to 0. So, two lines, say L1 and L2 are coplanar. So, use these conditions. A line to be on coplanar, it must satisfy these two conditions. So, first condition is a x1 plus b y1 plus c z1 plus d is equal to 0. A into a plus b into b1 plus c into c1 is equal to 0. So, these two conditions are for line L1 on the plane. Similarly, for the line L2 to lie on the plane, a into x2 plus b into y2 plus c into z2 plus d is equal to 0, a into a2, b into b2 plus c into c2 is equal to 0. So, these two are for line L2 on the plane. Now, if we represent by equation 1, 2, 3, 4. So, we have 4 equations. Now, subtracting equation 2 minus 1, we have a into x2 minus x1 plus b into y2 minus y1 plus c into z2 minus z1 is equal to 0. And other two equations as it is, we will represent a1, b b1 plus c c1 is equal to 0, a2 plus b b2 plus c c2 is equal to 0. Now, we have 3 equations and 3 unknowns, that is a, b, c. So, by eliminating unknowns a, b and c. So, by eliminating a, b and c, we have a determinant, that is x2 minus x1, a1, a2, y2 minus y1, b1, b2, z2 minus z1, c1, c2 is equal to 0. So, this is the conditions that two lines are coplanar. So, how to check that is two lines are coplanar? Suppose we are given two lines, that is 3x plus 1 by 5 is equal to 3 minus y by 2 is equal to 2z plus 1 by 3, and x plus 1 by 4, y minus 3y minus 1 by 4 is equal to 5 minus 2z by 3. Verify whether two lines are coplanar. So, suppose this is line L1 and this is line L2. So, how to check these two lines are coplanar? By using this formula, but before using this formula, we have first to write the two lines in its standard form, that is x minus x1 by a1 is equal to y minus y1 by b1 is equal to z minus z1 by c1, x minus x2 by a2, y minus y2 by b2, z minus z2 by c2 in this standard form. So, that is by taking 3 commons, that is x plus 1 by 3 divided by 5 and taking minus sign common from here, because coefficient of y is minus 1, that is minus 1 common, that is y minus 3 divided by 2 is equal to taking 2 common, that is 2 into z plus half divided by 3. Now, by 3 both sides, numerator denominator, and minus 1 in 2, and the second line is x plus 1 by 4 is equal to 3 into y minus 1 by 3 divided by 4 is equal to minus 2 into z minus 5 by 2 divided by 3, by minus 2 dividing and 3. So, we have in its standard form. So, what is here? x1, y1, z1. So, the point on line L1, that is x1, y1, z1 is obtained by equating 0 to each of the term. So, x plus 1 by 3 is equal to 0. So, that is minus 1 by 3, 3 minus 1 by 2. So, that is by putting each term equal to 0. So, that is point on L1. Similarly, point on L2 by equating each of the term to be 0. So, x plus 1 is equal to 0 is minus 1, y minus 1 by 3 is equal to 0, that is 1 by 3, and z minus 5 by 2 is equal to 0, that is 5 by 2. So, this is 2 point, that is x2, y2, z2. So, these are 2 points x1, y1, z1. Next, we have the direction ratios. So, the direction ratios are 5 by 3 minus 2, 3 by 2. So, direction ratios of L1 are 5 by 2 minus 2, 3 by 2, and direction ratios of L2 are 4, 4 by 3 minus 3 by 2. So, this is your A1, B1, C1 and A2, B2, C2. Now, we can have the determinant x2 minus x1. So, that is minus 1 plus 1 by 3, then 1 by 3 minus 3, then z2 minus z1, that is 5 by 2 plus 1 by 2, and A1, B1, C1 is 5 by 2 minus 2, 3 by 2, 4, 4 by 3 minus 3 by 2. So, this is on simplifications gives 2 by 3 minus 8 by 3, 3, 5 by 2 minus 2, 3 by 2, 4, 4 by 3 minus 3 by 2. So, this is determinant. We can expand this determinant by 2 by 3 into 3 minus 2 plus 8 by 3 into minus 15 by 4 minus 15 by 4 minus 6 plus 3 into 20 by 6 10 by 3 minus plus 8. So, that is equal to 2 by 3 into 1, that is 2 by 3 minus 39, 8 by 3 into 39 by 4 plus 3 into 34 by 3. So, that is on simplifications gives 2 by 3 minus 12 plus 34. Obviously, this is not equal to 0. So, these two lines are not coplanar. So, next we have in vector form, that is two lines are coplanar or not. Suppose the two lines are in vector form. Suppose the two lines are L1, that is R vector is equal to A plus A1 plus T times B1, and L2 A2 plus T times B2 vector, and the plane is R dot n vector is equal to D. So, these two lines are coplanar. Now, the condition is R scalar triple product R B1 B2 is equal to A1 B1 B2, or R B1 B2 is equal to A2 B1 B2. So, this is the conditions that two lines are coplanar, that is in vector form L1 L2. This is two lines whether they lie on a plane. So, this is the condition, that is whether these two lines are in coplanar or not. So, finally, we have shortest distance between two lines. So, if two lines are intersecting, then shortest distance between them is 0. So, if two lines intersect, then shortest distance between them is 0. If two lines are not coplanar and skew lines, so suppose the two lines are not coplanar or they are skew lines L1 and L2, they lie not in a plane. So, two lines will be are intersecting if they are coplanar. If they are not coplanar and they are skew lines, the shortest distance, then shortest distance we can represent by SD. Shortest distance between them is distance perpendicular to both the lines. Is shortest distance is the distance which is perpendicular to both the lines. Suppose PQ is the shortest distance, then PQ is perpendicular to L1 and PQ is perpendicular to L2 also. So, this is the shortest distance provided the two lines are not coplanar. So, what will be the shortest distance which is not perpendicular, which is distance that is perpendicular to both of the lines, they are not coplanar. Suppose these two lines are x minus x1 by a1, y minus y1 by b1 is equal to z minus z1 by c1, x minus x2 by a2 is equal to y minus y2 by b2 is equal to z minus z2 by c2. Suppose this is L1 and L2, these are the two lines. Now, the shortest distance between them is determinant x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 determinant divided by root over of a1 b2 minus a2 b1 whole square plus b1 c2 minus b2 c1 whole square plus a1 c2 minus a2 c1 whole square. So, this is the shortest distance between two lines. So, if two lines are coplanar, then the numerator term is 0. So, provided the two lines are not coplanar, the distance between them will be the shortest distance. So, that is in vector, that is in Cartesian form or in vector form. In vector form, suppose we have the two lines, that is r vector is equal to a1 plus t times b1, r vector is equal to a2 plus t times b2, that is in two lines in vector form. Then the shortest distance between them is equal to a2 minus a1 cross b1 cross b2 divided by magnitude of b1 cross b2. So, that is the shortest distance between two lines in vector form, and this is in Cartesian form. So, we can take one example, that is shortest distance between two lines. We can take one example, that is, suppose r vector is equal to 3 I cap minus plus 8 j cap plus k cap plus t times I cap minus j cap plus 2k cap, and r vector is equal to 2 I cap minus j cap plus k cap plus t times 3 I cap minus j cap plus 4k cap. Shortest distance between two lines. So, we can here a vector a1 is equal to 3 I cap plus 8 j cap plus k cap, and b1 that is equal to I cap minus j cap plus 2k cap, and a2 vector is equal to 2 I cap minus j cap plus k cap, and b2 vector is equal to 3 I cap minus j cap plus 4k cap. So, the shortest distance is a2 minus a1 vector, that is equal to minus I cap minus 9 j cap, and b1 cross b2 is equal to determinant I j k 1 minus 1 2 3 minus 1 4, that is I cap into minus 4 plus 2 minus j cap into 4 minus 6 plus k cap into minus 1 plus 3. So, this is on simplification minus 2 I cap plus 2 j cap plus 2 k cap, and magnitude of so this is dot product, magnitude of b1 cross b2 is equal to root over of minus 2 square plus 2 square plus 2 square, that is equal to 3 2 root 3 root over of 12, that is equal to 2 root 3. Next a2 minus a1 dot b1 cross b2. So, their dot product will be minus 1 into minus 2 plus minus 9 into 2, that is equal to 2 minus 18 minus 16. So, the shortest distance is equal to minus 16 by 2 root 3. So, it is always positive. So, that is equal to 8 by root 3. So, this is the shortest distance between two lines. So, we can have one more example of straight line, that is say image of minus 1 3 with respect to plane 3x minus 2y plus z minus 9 is equal to 0. So, what is the image of this point with respect to plane? Suppose the point is a point having coordinate 2 minus 1 3, and the plane is 3x minus y plus z minus 9 is equal to 0. So, image of A is B. So, we have to find the coordinate of B. So, AB is normal to plane. So, direction ratios of normal AB is the coefficient of x y z, that is 3 minus 1 1, that is 3 minus 1 1. So, equation of AB is x minus 2 by 3 is equal to y plus 1 by minus 1 is equal to z minus 3 by 1. Suppose this is equal to r, then P point, their intersection point is x is equal to 3r plus 2, y is minus r minus 1, z is equal to r plus 3. So, P point is 3r plus 2 minus r minus 1 r plus 3 on the plane 3x minus y plus z minus 9 is equal to 0. So, it will satisfy this equation, that is equal to 3 into 3r plus 2 minus r minus 1 plus r plus 3 minus 9 is equal to 0. So, that is 9r plus r 10r plus r 11r plus 6 plus 1 7 plus 3 10 minus 9 1 is equal to 0. So, that is equal to 6 plus 1 plus 3 minus 9 is equal to 0. 11r plus 1 is equal to 0. So, r is equal to minus 1 by 11. So, P point is minus 3 by 11 plus 2 minus 1 by 11 minus 1, that is minus 1 by 11 plus 3. So, that is P point is, so P point is coordinate 8 by 11 minus 10 by 11 32 by 11. So, this is coordinate of P, that is 8 by 11 minus 10 by 11 32 by 11. So, image B has the coordinate twice of midpoint, that is 2 into 8 by 11 minus 2, y coordinate 2 into minus 10 by 11 minus of minus 1 and 2 into 32 by 11 minus 3. So, this is on simplifications gives B point, that is minus 6 by 11, y coordinate is minus 9 by 11 and z coordinate is 33 minus 64. 31 by 11 is image of A with respect to plane. So, this is all about straight line. So, we have read equation of straight line in symmetric and unsymmetric form, and both vector and Cartesian form of straight line, angle between two lines, angle between line and a plane, and condition of coplanarity of two planes, and shortest distance between